Okay, we're going to start our exploration of the toolbox functions and their transformations. Sometimes we call toolbox functions parent functions, and I'll refer to those, the toolbox functions and parent functions, they're interchangeable. Toolbox functions or parent functions are the most basic functions that we deal with in math. Currently, the ones that you're equipped to deal with are y equals x. Okay, and we have a chart here showing some of the values of y equals x around 0 and its graph. Y equals the absolute value of x. Okay, has a V shape when you graph it. Y equals x squared, which we should be familiar with, parabolas. Y equals the square root of x. Okay, and if you look in the chart here, we'll want to notice a couple of things right here where it says, has this symbol. I did this in Microsoft Word, and that's what happens when, no, I'm sorry, Excel, when you get imaginary numbers. Okay, here we should know that if we put -1 in for the square root, that this is actually I, and then the one above that would be the square root of 2i. Okay, down here in decimal form, that's actually the square root of 2. So we need to understand that. And again, these points are plotted. Okay, 0, 0, and 1, 1 are plotted on all of these functions, and that's the chart is a representation of some of the values on the graph. Our second to last graph is y equals x cubed, and lastly, probably the one that you haven't seen a ton of, is the cube root of x. Okay, and here are some values, and let's make sure that we understand that this value is the cube root of -2, and the value at the bottom of the chart here is the cube root of 2. Okay, notice that 1, 1 is a point on all of these graphs, and 0, 0 is a point on all of these graphs. That comes in handy when we start looking at shifting these graphs. Okay, let's take a look at a quick problem here. Graph the parent function of x plus 2 quantity squared minus 1 and the function f using the chart below. Describe the transformations that you would perform to the parent function to end up on the graph of f of x. Okay, first off, we need to identify the parent function of f. In this case, we have a squared here. So that kind of tips us off that our parent function in this case, which for just this example I'll refer to as p of x, is x squared. So really what we have here, we're going to graph that in blue, is x squared. Now if we wanted to graph x squared, we have the chart up above, but I would put in -2 and square it, which would be 4, -1 and square it, which is 1, 0 in and square it, which is 0, 1 in, square it, which is 1, and put 2 in and square it, and that's 4. Okay, so here's our graph of y equals x squared, right? At 1 we have the point 1, 1, at 0 we have the point 0, at 2 we have the point 4, and I should have went the other way too. -2 we have the point 4, at -1 we have the point 1. So here roughly is our graph of x squared. Okay? Now, the function that we're actually asked to graph, which I'm going to put in red here, is x plus 2 squared minus 1. You got to think about this pretty quickly here. If I put in -2, -2 plus 2 squared is 0, 0 minus 1 is -1. If I put in -1, I get 1 squared minus 1, which is 0. If I put in 0, I get 2 squared, which is 4, minus 1, which is 3. If I put 1 in, I get 3 squared, which is 9, minus 1 is 8. If I put 2 in, I get 16. Well, I get 4 squared is 16 minus 1, which is 15. Okay, some of these values clearly will not fit on our graph, but we can just take a look at it. So, at x equals -2, we get -1. Okay. At x equals -1, we get a 0. At x equals 0, we have a 3. And then after that, it's going to take off out of our graph. Now, what we can kind of see here is that this portion of our parent function seems to be corresponding to that portion of the function that we called f of x. So I think it's going to be safe to say here, if you look, that we could actually plot these other points here. Okay, and I'm basing that plot off of my parent function, which gives me the general shape of the function that this then is corresponding to this portion of the graph. And what we see here is describe the transformations that you would perform to the parent function to end up on the graph of f of x. You'll notice that what we did here was we had a shift over and down. We shifted, each point was shifted 2 to the left and down 1. Okay, and so that's what we're looking for when we say that we the transformations we would perform to the parent function, which was x squared, to get x plus 2 quantity squared minus 1. Quickly here, what I would like to do is take a look at this on a graph. So quickly here, I'll just put load up. Here is the graph of x squared. Seems a little confusing because I had it in blue, so I'll just change that really quickly here. Okay, so there's our graph in blue, and now what I'm going to do is I'm going to copy that into our input bar here, and if you watch what I type in, I'm going to put plus 2 minus 1. Okay, so there's the graph that we plotted, and we'll take a look at that quickly here. And if I change it to red, okay, it should look a lot like the one that we have on our. You'll notice we were shifted to the left 2 and down 1. If you look up here in this toolbar, what the program actually does is it multiplies it out, squares that quantity, and subtracts 1. That's it for this portion of the notes.